we might first label these and color code them. Alright, where do they intersect? They intersect when theta is pi over 6 or 5 pi over 6. Read the question carefully. They didn't ask us to find the values of theta, they asked for the points. The points are, polar points are theta, 2 pi over 6 and 5 pi over 6. You could convert them to rectangular coordinates, but why would you do that? It doesn't ask you to. That's extra work. But you could, and you would have gotten, and we get root 3, 1, and negative root 3, 1. You do want to communicate which form you're using by saying x, y, or r theta. Of course, we got those rectangular coordinates by using x is r cosine of theta and y is r sine of theta. Alright, next let's find the area of the shaded region. And let's blow this up a little bit. So the bottom half is just a circle, so 1/2 of that circle, where the radius is 2 pi. And now I need the top half. The top half in quadrant 1 is exactly the same as in quadrant 2, so we'll just find the area in quadrant 1 and double it. So we've got the bottom half, and the top half will be 2 times the area in quadrant 1. Alright, to find the area in quadrant 1, you need to think of that windshield wiper, the radial arm that rotates, and we need to consider 2 different regions. As it sweeps from here to there, when the boundary is the red curve, and then the region as it sweeps from here to here, when the boundary is the green curve. We already know that this point is when theta equals pi over 6, so as theta goes from 0 to pi over 6 for the red curve, 1/2 r1 squared d theta, and as theta goes from pi over 6 to pi over 2 for the green curve, which is 1/2 times r2 squared d theta. I didn't have room, or I would have written the entire thing. Alright, when we enter this into our calculator, let's see what we get. And so when we add the bottom half, which is around 6 or 6.5 or so, plus the top half, which is this expression, we get approximately an area of 10.37047 square units. And that's our answer to part B. Alright, let's take a look at part C. Alright, so we need to find the time t when the x-coordinate is -2. So we know that the x-coordinate is r cosine of theta. And for the green curve, this is the x-coordinate. And we need the x-coordinate to be -2. So let's go ahead and put that in. So we have -2 equals 3 minus 2 sine of theta, but theta is t squared. So we'll substitute t squared in for theta. Alright, now that that substitution's been completed, let's solve this equation. We'll use our calculator, entering this entire equation as y1. When we add 2 to both sides, we have this expression is equal to 0. So we'll let that expression equal y1, and we'll find the zeros of y1. And of course, we'll only consider the zeros that are between 1 and 2 inclusive. And that's true when t is about 1.6503. Alright, that's our answer. And by the way, this graph is bonkers in the standard window. Check it out. When you zoom into just from 1 to 2-ish, or 0.5 to 2.5, it's not so bonkers, but look at this graph in the standard window. It's wild. Alright, onward to part D. So they're asking for a position vector. Recall these fundamentals. We can use any letter, it's arbitrary for position. Our book has been using R. The position vector is defined in terms of its horizontal component and its vertical component. The velocity vector v and the acceleration vector a. Alright, so let's come up with our position vector for this object in terms of t. Well, as usual, the x-coordinate will be r cosine of theta, and the y value is r sine of theta. But for part C, theta is t squared. and r is 3 minus 2 sine of theta. So this is the horizontal and vertical component, and we now have the position vector because we just defined it in terms of the horizontal and vertical component. So vector r, the position component, or vector, the position vector is that. All right, next, what's the velocity vector when t is 1.7? So for velocity, we'll need to take the derivative of both of these. This is the product rule and the chain rule. A lot of calculus going on for differential calculus, but we could also just use our calculator for this. Trust me, you definitely want to learn how to use your calculator to do problems like this, because this took me about 15 seconds, whereas finding the actual derivative and then substituting in t equals 1.7 probably would have taken me 3 to 5 minutes. All right, there's the answer for part D. I hope that this video has helped you to understand a problem like this.